Okay, this is the third and final video for the lesson from Friday. It's a fairly long lesson. You have 2 days to get it done. 3 days really, Friday to Monday. And but it's a critical topic. It's balancing equations. So I've been balancing the equations, the first 10, in a couple of different ways. Here's a fairly simple looking one. So let's try to just do this one intuitively without drawing boxes, all right? So you have one phosphorus here and you have 2 here. So to get those to balance, you're going to have to put a 2 here. Again, I'm writing it up here because I don't know that that's going to be the final number. So until I know I have my final numbers, I just write them up above. Okay, so phosphorus is in balance. Now oxygen. Well, the oxygen is out of balance. So I have a 2 here and a 5 here. So look for the least common multiple of that, and that's going to be a 10. 2 times 5 is 10. Those two numbers don't go into any number smaller than 10. So I'm going to put a 2 here, and I'm going to put a 5 here, because I need to make both of them multiply to 10. 2 times 5 is 10, and 5 times 2 is 10. So now oxygen is in balance. However, in doing that, I threw my phosphorus, which I now have 4 there, I threw this one out of balance. When that happens, sometimes you'll put one in balance and then it gets thrown out of balance temporarily until you get to the end of the problem. So now I need 4 phosphoruses, so I'm going to come over here, and you can either erase or just scratch it and change it to a 4. So now I have 4 phosphorus, I have 10 oxygens, and I have 10 oxygens. Remember, coefficient applies to both. It applies to all of the elements in a compound. So there you go. So there is 4, 5, and 2. Okay? And that's your final answer for that. Okay, we're going to move through this. And what you're doing here is throwing sodium in water. That's actually volatile. It's slightly volatile. Forms sodium hydroxide and hydrogen gas. You don't want to be breathing that in. You do something like that in a fume hood. Okay, so what are we going to do? I don't know. What do you want to do this time? Let's do the box method. That's what I want to do. I didn't hear what you wanted to do. And I got ants on my paper, so I got to get tough with them here. All right, and then we got H2O. I got ants on my hands here. Okay, I got H2O. So again, I'm going to write the H's separately. I'm going to break them into their elements. I'm going to come down here, make a box here. I got sodium, I got oxygen, I got hydrogen. All right, and over here I have 2 hydrogen atoms. The hydrogen molecule, but they are hydrogen atoms, 2H and an H. All right, so H and H there. All right, so what do we have to do? Sodium is in balance. Hydrogen, I have 1. Again, draw a line underneath your arrow to remind you which side is which. So I have H, H, and H there. Here I have 2 H's, so I simply add a box because there are fewer H's on this side. I'm going to add another water molecule. Now over here I have 1, 2, 3, 4 H's, and here I still have the 3 H's. So I have to add one more box to one of these. I want to get 4. If I add it here, I'll end up with 2 more H's, so that would give me 1, 2, 3, 4, 5. That's no good. If I add it here, I end up with 1 more. So I'll end up with an H, another H, and these 2. That will give me 4. So I had a choice which one to add it to. I'm going to add it to this one. So now I have Na, O, and H. So now my hydrogens are in balance. 1, 2, 3, 4. 1, 2, 3, 4. How about oxygens? They're also in balance. 1, 2, 3, 4 oxygens. And how about sodium? There's 2 on this side and only 1 on this side, so I need to add a box there. Na, and it looks like everything's in balance. So we just go ahead and we count our boxes. So we have 2 there, 2 there, 2 there, and 1 there. And that takes care of that. Okay, go ahead and do this one intuitively. You got 2 silvers on one side and 1 on the other. You got 2 oxygens on the product side and only 1 on it. So let's just go ahead and pretty easy one. Here you have 2 here and only 1 oxygen here, so I need to make 2 oxygens. So now I have 2 oxygens, 2 times 1. and this is a coefficient is a 1, 1 times 2. And now silver. I have 2 times 2 is 4, so to balance that I have to put a 4 there. So everybody's in balance, so I have 2, 4, and 1. And that balances out everything. All right. Okay, I'm gonna tell you in advance, this one's gonna be a mess if you try to use the box method. Again, the box method, it's always good, but if you might end up with 10, 20, 25 boxes under one element, it gets a little crazy. So if you can do it intuitively, do it intuitively. All right, we only have 2 elements, so I have 1 sulfur there and 8 there, so I'm going to put an 8 here. Okay, so I have 8 sulfurs here, 8 times 1, and right now, as of right now, it's 1 times 8, so sulfur's balanced. Now all of a sudden I created 24 oxygens. That sounds like a big number, but what do I have to multiply 2 by to get 24? How many of these am I going to need? I'm going to need 12 of these. Okay, so very simply my answer is 1, 12, and 8. So sometimes just doing it intuitively, if it's a simple equation, is just as good as anything else. Okay, let's go on to this one. All right, so what we have here is, you may recognize this reaction from biology. This is the photosynthesis reaction. Carbon dioxide and water gives you a sugar and oxygen. All right, so let's do this. Let's do this using, what do we want to use this time? Well, I see the hydrogens are going to be fairly easy. I'm going to go ahead and use the box method here. Again, that's the one that's good for you. So it's COO. Water is H and O. I'm going to draw a line. Don't get confused. So now I got a whole lot of things here. C, 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 C. Then I got O, 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 and then I got 12 H's. I won't say that 12 times. It'll drive you crazy. Okay, there you go. And then oxygen over here is 2 O's, O and O. All right. So what are we looking at here? Start wherever you want, really. I usually start with something that only appears once on each side. Let's go for carbon. So there's 6 here. So that means I'm going to need to draw 6 of those boxes. So I better make them kind of smaller. I'm going to need 6 of those boxes. So I have COO, COO. And if you want to just save yourself some time, just do that. You got the same thing. Okay, so you now have 6 carbons over here. I'll write them out. See, you got 6 C's there, you got 6 C's there, carbons in balance. How about hydrogen? We got 12 there, and we got 2 there. So in order to get this up to 12, I go to the one with the least. So again, I'm going to make these a bit smaller. So now I have 12 hydrogens on this side, 12 on this side. Okay, and hopefully at this point, since we've got carbon and hydrogen balanced, hopefully oxygen balances. So let's see what we got. This is a big one. You got 12 oxygens here in the CO2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then on the same side, you have 1, 2, 3, 4, 5, 6. So you have 18 oxygens. Okay. Over here we have 1, 2, 3, 4, 5, 6. And we need to have 18. So we're going to have 12 more. Again, we have 6 here. We have a total of 18 over here. So we need 12 more, or we need 12 in all. So we're going to go ahead and create a couple more O's here. Okay, so now we have 12 oxygens here and 6 more right there on the product side. That's 18. We have 6 here and 12 here. That's also 18. The carbons stayed in balance. The hydrogen stayed in balance. So we've got 6 boxes. We have 6 boxes. We have one box here. I didn't leave myself a space to write it, so I'll put it right there. 1. And then we have 6 boxes down here, and that is your answer. 6, 6, 1, 6. All right. Now, when you get into some of these hydrocarbons, they get to have some pretty big numbers of coefficients. Okay, what are you going to do? Do this one intuitively. What do we got? This is called a single replacement reaction. You have MgBr and a lone element of K, and the K takes the place of the magnesium right there on the product side, and the magnesium becomes a lone element. It's called a single replacement reaction. One of the elements was replaced by another. All right, so we've got a 1 and a 1 here. We got a 1 and a 1 here. We've got a 1 and a 1 here. Hey, what do you know? It's already in balance. You don't have to write the coefficients, except in this class you do. So there you go, 1, 1, 1, 1. Okay, so here we got what looks like a fairly complicated reaction. We can start with, I'm going to do this one kind of intuitively. So I have a calcium, they're already in balance. I have 1 chlorine here and 2 chlorines there, so I'm going to put a 2 here so that I now have 2 chlorines, 2 times 1, and here's a 1, so it's 1 times 2. Again, we're working through this problem. Those numbers could change. All right, when I did that, I created 2 hydrogens here, and I have 2 hydrogens here, so hydrogens are in balance. So hydrogens are in balance. Chlorines are in balance. Carbons are already in balance. And I didn't leave myself a line there. Carbons are in balance. You have a C and a C. So the only thing left is oxygen. All right. So I haven't changed any of these coefficients. So I have 2 there and 1 there, and I have 3 there. So they're in balance. Right there, put a 1 right there. All right. And so what I end up with is 2, 1, 1, 1, 1. Now again, that's just doing it intuitively, and you'll get to where you can do that. If you want to see me do it with the boxes, I'll do it with the boxes. Okay, just takes a little bit of writing. HCl. Over here is C, A, C, and 3 O's. Over here is a calcium and 2 chlorines. Over here, water. And over here, carbon dioxide. Okay, there you go. All right, so what are we looking at? So we have 1 hydrogen here, 2 here, so I'm going to draw another box here. Okay, so now we have 2 hydrogens here, 2 hydrogens here. We have 2 chlorines here, we have 2 chlorines there. We have 1 calcium here and 1 calcium there. We have 3 oxygens here, and we have 1, 2, 3 oxygens on that side. So everything's in balance. So I have 2 boxes, and then 1, 1, 1, and 1. Okay? Not always that hard. Okay. Next up. All right. So we're going to put these together. Let's use boxes on this one. And let's see what we got. Well, let's just check what we got. We got 1 hydrogen here and another one here. So here's our line down the middle. So we got 2 hydrogens here, 2 there. Let's look about nitrogen. We got a nitrogen here and another one here. That's 2 of them. Check that. I wrote this down wrong. That's CO3. That's a C. I did not copy the problem correctly, so I'm going to start over here. So HNO3, let me just double check it. NaHCO3, NaNO3, H2O, CO2. Okay, so you got an H here and an H here, so that's 2 on the left side on the product, on the reactant side. You've got 2 on the product side. You go to N, so you do only have 1 N on the reactant side, and you have 1 N on the product side. You have, how many oxygens do you have? You have 3 here and 3 here, that's 6. And here you have 3, plus 1 is 4, plus 2 more is 6. And I think we covered everything. Oh, you got a carbon here and a carbon here. So everything's already in balance. So we're done. So you can always check an equation first through and see if it's in balance before you start drawing all the boxes. Everything there is a 1. Next up. Okay, this is water and oxygen to give you hydrogen peroxide. This is the stuff you can buy in the drugstore. Use it to whiten your teeth or bleach your hair, or do all kinds of things. Okay, let's do this one intuitively. Hydrogens are already balanced. On this side we have 3 oxygens, on this side we only have 2. Okay, so I'm going to leave the hydrogens alone. Let's see what happens. Actually, this is a good one for the box method. Let's draw the box. Because you're going to have a least common multiple situation. All right, so hydrogen's balance. We have 4 on this side, and I take that back. We have 3 on this side. That's supposed to be too many. So there's only 1 oxygen here. 1 oxygen. Okay, so we have 3 on this side and 2 on this side. So we're going to need, the least number is 2, so we're going to need to add another box. So now I have 1, 2, 3, 4 on the right and 1, 2, 3 on the left. Now the least number is over here. I need to get 4. Okay, if I add a box here, then I'm going to have 2 more. So I have 1, 2, 3, 4, and then 5. That's not going to get me to 4. If I add the box here, then that's what I really want, because that gives me just the right number. 1, 2, 3, 4 versus 1, 2, 3, 4. I still have the hydrogen, so I got 2 boxes, 1 box, 2 boxes, so 2, 1, 2, and that's that. All right, a couple more to do and we're done. Now we can do these in class, or you can do these at home. But I formally told you in the last assignment, if you want to do just 1 through 10, you're okay. All right. So let's do this. Sodium bromide, okay, and what do we got here? So this is what is called a double replacement reaction. The sodium bromide, you have compounds with 2 elements. So the sodium swaps places with the calcium, and the bromine with the fluorine. So instead of NaBr, you end up with NaF. They switch dance partners, is the way I like to think it. Instead of CaF, you end up with CaBr. That's called a double replacement reaction. 2 of the elements were replaced. Okay, let's just draw the boxes. That's going to be your method until you feel comfortable that you can be weaned from that and not have to use that. Okay, let's just figure out something to balance. Sodium's already in balance, so nothing to do there. Bromine, I have 2 on this side. Draw my line here. 2 on this side, 1 on this side. So I'm going to draw another box over here. Okay, so bromine's in balance. Sodium's now out of balance. So bromine's in balance. Sodium, there's 2 now on this side and only 1 over here. So I'm going to go ahead and rebalance sodium. Started off balanced, then it got thrown out of balance. Okay, so sodium's in balance, bromine's in balance. Now fluorine. Fluorine, we have 1, 2 on this side. We have 1, 2 on this side. So now fluorine is in balance. So I have 2, 1, 2, 1. And bang, we're done with that. Okay? That is an F right there. Okay, here we go. 1 more to go, and we're done with this assignment completely. Okay, so we got sulfuric acid, and we're going to get my focus here. Okay, hopefully that stays in focus. All right. Okay, let's go. Draw a box. Got a lot of stuff in it. H, H, S, O, 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 O. Na, N, and O, O. H, N, and you got 3 O's there. Okay, so let's stay away from oxygen. There's oxygens all over the place. It's crazy. It will do that one last, and you'll probably find that when we do hydrogen and sulfur and nitrogen, that the oxygen ends up in balance. Okay, so what do we got? Hydrogen. Draw my line down the middle. So I got 1 on this side. I got 2 on this side. So I'm going to draw another box here. Okay, so hydrogen's good, at least for now. Sodium. I got 1 on this side, and I've got, I didn't draw this correctly. I should have a second sodium there. It's N2. N2 should have 2 sodiums. So I have 1 on this side, 2 on this side, so I need to draw another box where I have the least number of sodiums. Okay, sodium's in balance. How about hydrogen is in balance? No? Yeah. Yeah, we drew the second one. Our hydrogens are in balance. Our nitrogen, we have 2 here, and we have 2 here now, so we're okay with that. So hydrogen, sulfur, sodium, and nitrogen all look good. So now we have to balance oxygens. And if we're lucky, they're already in balance. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so they're not in balance. They are in balance, I'm sorry. 1, 2, 3, 4. Okay. I always blame it on being tired. I made a mistake here. I hope you caught it. It's HNO2, not HNO3. That's why I wasn't balancing here. So let me change that. It didn't really bother us because we're just getting to oxygens, and I discovered my mistake because I couldn't get it to balance. So there should have only been a 2 here, 2 oxygens, and 2 oxygens here. Okay. All right. So HNO2, there's 2, there's 2. So we now have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Everything's good. So I have 1 here, 2 here, I have a 2 here, and a 1 here, and that takes care of it. Guys, we're going to practice these a lot. You're going to do these every day. You will get good at these, okay? Don't get frustrated at first. I think the box method is the best method for you, and then you can start doing them a little more intuitively. All right, have a good day, and we'll see you in class Monday.